Okay, this is constructing medians. So I am going to be constructing the medians of this triangle, and they are going to come to a point of intersection, and we will find out exactly what that intersection is. But first of all, I have to have a triangle, so I have triangle ABC. I'm going to construct the midpoint of segment AB. So this is segment AB, so I have to construct the midpoint. The way you do midpoint is by doing perpendicular bisectors. So, start with your needle. If we're doing this segment, you start with your needle at one of the endpoints of the segment. Open it up past the halfway point. You're going to do an arc above, arc below, or an arc to the left, arc to the right. Without changing the length or the opening of the compass, you're going to do the exact same thing from A, from the other point of the segment. Arc above, arc below. These intersect, these do not, so you need to make sure that they intersect here. And once you have the intersection of the two arcs, you connect. Connect to find actually where the midpoint is. So once you have the midpoint, then you can actually label that M. And then we have, we can erase our excess here, because we do not need this. Now, that's our midpoint. In order to construct the median, we're going to have to do a segment from the median, the M point here, to the opposite vertex. So I'm going to take my ruler from the midpoint to the opposite vertex C, and there's our median. Now, again, you have to make sure you have your proper labeling. Since this is a midpoint, you have to make sure that you label this properly. Now, in order to construct all of the medians of the triangle, you need to make sure that once we do AB, you have to now do BC and AC as well. So I will demonstrate this. We have past the halfway point, we're going to do BC, past the halfway point, arc above, arc below, C, do the exact same thing, arc above, arc below. Try and make sure that your needle does not move. These two do not match up, so I need to make sure that I extend this arc here. So now I have an intersection here, intersection here. Okay, so when I intersect these, this is my midpoint. If I want to be consistent, make sure you're labeling your two congruent parts, then you can erase your excess. Excess here, because that's one of our medians. We don't want to erase that. Okay, so now I can construct the median because this is your midpoint, the opposite vertex. Think of the angle that is opposite this as like a mouth, and it's eating the midpoint, so you can tell which one is actually, you have to draw the line to. So I have to draw the line to A, vertex A. Okay. So I have a median to C, I have a median to A, now I have to do a median to B. So you're basically constructing, if you want to put, I don't know, an X here, I'm constructing all the medians. If it just says construct one, then all you have to do is do one. But I'm constructing all of them. Past the halfway point, arc above, arc below, or arc to the left, arc to the right. Arc above, arc below, arc to the left, arc to the right. And make sure that they match up. Again, here, I didn't go far enough, so I need to make sure I go far enough. Connect your arcs where they intersect. That's your midpoint. You can label your midpoint using random letters. Okay. once you have that, again, you have to make sure you label it properly. So we have 1, 2, 3, 1, 2, 3, signifies the midpoint. And then I can connect, since this is my midpoint here, opposite the vertex. Remember, the angle B is going to be eating this midpoint, so you'll connect it to angle B. And if you do everything correctly, all your medians should intersect at a point, called your point of concurrency. Okay. So, the medians are basically called all the points of concurrency. This is called your centroid. So I'm going to label my centroid as Z. So centroid is point Z. The reason that this is important is because I could take any one of these lengths. For example, let's do the first one that we actually constructed. We have the length of CM. If I do the entire length of CM and take 2/3 of that, that will equal CZ's length. And you can do that all around this triangle. Again, for example, let's do A to X. So if I took the entire length, AX, cut that in 2/3, that would be equal to AZ's length. And that's from your module notes. So that's medians and centroid.